Hey everyone, it's Orkan. Welcome to my channel. Today we are going to solve LeetCode 113 path sum 2 problem. So the problem statement is that we are given a root of a binary tree and an integer target sum, and we need to return all root to leaf paths where the sum of those paths is values of those nodes. They are equal to target sum. So also there is an explanation what is the root to leaf. Root to leaf is the path starting from the root and ending with the leaf. Leaf is the node which has no children, right? So for example, we are given an example. In this example, the sum of these two paths, for example, from here to here and from here to here, is equals to our target sum is 22, so in this case it equals to 22, and in this case it also equals to 22, so we are returning them as a result. Also we need to return them not as a list of the we need to return the list of the node values, not the node references. So that's the requirement. All right, let's see how we are going to solve this problem. Let's take one example. Let's say we have 4 and we have here 5, we have here 3, and this one, the value of this one is 1, for this one is value is 6, and let's say for this one the value is 4, and for this one is value is 8. Okay, and let's say that our target is equals to 17. Okay, our target is equals to 17. So what we are gonna which algorithm we are going to use here? Since it's a binary tree, so every tree is a form of graph, so the approach that we are going to use here is DFS approach, deep first search. So we are going to go deep in each branch of the tree and see that if the values sum up to our target. For example, let's go on this branch. It equals to it's not equal to 17, it's equal to 8, so we are not taking this one. On this one it is equals to 13, so also not qualified. This one is equals to 13 again, not qualified. And for this one we are taking the value because it exactly equals to 17, so only this one we are returning as a result. And the base case for us is when this sum is equals to our target, when this sum will be equal to our target. Okay, that's the base case when we are gonna backtrack from this branch, let's say. That's it. Let's put this solution to code. Things first, we need to create a list of lists that will contain our result, which we are going to return. Okay, let's just call it result, and let's initiate it. It's array list. Okay, so the next things that we are going to do, we are going to create a method. Let's call it the first search. And what we are going to pass there, we are going to pass our root node, and we are going to pass our target sum, which we want to meet, and the sum, which will start with the 0. Also, we are going to create a temporary array where we are going to store, once we go over our each branch, we are collecting the values of that in our temporary array, in our temporary array list. So let's initialize that also, array list, and also we are going to pass the result. Okay, so we are going to collect all the results in our result, and we are going to return that at the end. Okay, and return the result. So now let's go to the main part, which is the our DFS, so which is gonna, it's not actually gonna return us anything, just a void. So let's call it DFS. And what we are actually passing here is, so tree node. Let's just copy paste this one from here. So we are gonna, so it, as an argument, it takes our tree node. So the next one is our target sum. So the next one is our current sum. Let's just call it sum. And also it takes our array list, which is, let's call it, let's just call it list, integer, let's just call it temp. And it also takes our list of list as a result, and which it's gonna return. All right, where we are collecting all of our results. All right, let's go to the next part, which is the first thing that we need to do. We need to check that if our root is equals to null, then in that case we just need to return. So we are just returning. So the next one is that what we need to do. We need to first of all add to our temp, add there our root value. Since it's not null, we can take its value. And the next thing that we need to add to our sum. So we need to add to our sum our root value. Okay, root value. Next thing that we are gonna do, we are gonna define our base case. In our base case, we are gonna say that, okay, if the root left is equals to null, and root right is equals to null, and if our sum is equals to target sum, which means that we are in a path that we need to, or we are in a path that sum of which equals to our target sum, so we can add that to our result. So what we say here is result add new array list. Why we are taking the new array list? If we are gonna add just temp, then it will point to the same array list in the memory. That's why we need to take the copy of the array list at the moment, which with our results, and add that to our result. So we are taking here temp, and so what the next thing that what we need to do, we need to call the DFS in recursively. So first we are gonna pass our root left, then our target sum, we are gonna pass our sum, we are gonna pass our temp, and we are gonna pass our result. Okay, so exactly the same thing that we are gonna do with right child. Okay, that's it. And at the end, in order to clean our temp array, not to store the values from another branch, what we are gonna do, we are gonna remove the last element once we are backtracking. So what we are gonna do, we are gonna say that, okay, temp size. So let's remove that the temp size -1. Okay, the last element from our temp. That's it. Let's check our code. Okay, great. It works as expected from the first time. So let's go over it one more time. So first thing that we are doing, we are creating our result, and we are creating our DFS where we are passing our result. Our result collects all the root to leaf where the sum is equals to our target sum. So first we are checking if it's null, then we are just returning. And the next thing is that we are adding to our temp our value, and we are adding that to our sum. If we are on the leaf where there is no left and there is no right child, then in that case, and the sum is equals to our target sum, so it means that that is the root to leaf. That's the branch where we have our result, and we are taking a copy of it, because otherwise all will be point to the same array list in the heap memory. And then we are just recursively calling the method. We are doing the DFS for the left and for the right, and not to so remove from the from our temp the values of the another branch. When we are backtracking, we are removing the last element. Okay, that's it. That's it for today. I hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.